Hello everybody, welcome back to the Bison Workshop. I'm Bob, and today we're going to attempt to fix my power supply for my mill. As everybody remembers, in one of my videos, right before I did the lead screw on my mill for power, every time I turned my mill on, it would arc. It sounded like an electrical arc. So I went ahead and took the power supply out of my 3D printer that I had spare, the one I just worked on and got working again. And because I was going to do the 3D printer and get it back up and going and working, I decided to take the power supply back off of the mill, and right now my mill has no power supply for the Z-axis. So I had gotten the motor to convert it to 12 volt, but it's just a lot of work that I don't want to do that's already done. The motor that's there and the pulley system that's on the Z-axis works fine the way it is. So instead of putting that motor on there and just use that motor for something else, a 12 volt motor, I decided to go ahead and put my 24 volt power supply back in production. So I did find out what was wrong with it, and I did order the parts. So we'll put you down here. I'm in my kitchen right now. I've got a stainless steel top on my stove that I don't use. It's a gas stove, so I don't use it. So I just kind of use it for a countertop. So as you can see, I got my monster Avenger in the background here. She sure is a pretty gun, man. But anyway, so we'll put you down here and we'll show you what we got. Alright, so I've already got the top off of it, and screws are all laying right there. But we're going to have to take this motherboard and everything out. So that requires us to have to take these 3 screws here out, which holds the heat sink, and these, I'm not sure what they're called. I don't know enough about these to actually name them by name. But anyway, then we got to take these screws out down in here and take this board out in order to get to the back side of it. So we're going to have to take these 2 out also. So I'll do that and we'll be back. Alright, so we're going to slide this on up out of there. And then we're going to set this out of the way. So now I'm going to get something to set this on because I don't want it touching the stainless steel. The simple reason is these capacitors still have charge in them. So I don't want these actually shorting against the stainless steel, so I just get something just to be safe. It may not be necessary, but in my mind, it is. So what I found was this thermistor right here. See, the top of it blowed off of it. And that is this bad boy right here. So we're going to put us a new one in there. Now I don't know if this will fix the problem or if it's just going to band-aid it. I don't know. But these here were like $6 or $7 for 10 of them. So why not have them in stock anyway? Because I'm always working on stuff like this, and you never know when you might need another one. A lot of things use these thermistors, and I'll show you an example. I've got my dehydrator over there in the corner, and I started using it yesterday to make deer jerky. So this one stopped working. Well, it's also got a thermistor in it, which I've already taken out so I can get the numbers off of it and get another thermistor. But this basically does the same thing. So I got that sitting there waiting for parts so I can fix my dehydrator. So now we're going to take and pull this out. So you want to make sure that you remember the orientation. Even if the orientation is not important, it's always a good idea to keep in practice to always treat things that way. So we see that the letters are on this side. There is no letters on the other side. So this is a NTC thermistor. It's a 5D-15. And although the package says it's a 510, or 510, but that ain't what's in it. It took me forever to get that part. Otherwise, this video would have been up a long time ago. So we're going to go ahead. I've already got the soldering gun ready. So we're just going to take and pull this out. And I'm just going to grab a hold of that so I can keep my stuff sitting still. And then we're just going to heat this one up. Pull it out. And there it is. It's that simple. Alright. So now I think I'm going to get my desolderer and get that solder off. Now, we have this. This is the one that came with it. This is one I had a long time ago. And I actually 3D printed that part right there, because this part broke. So I made a new one. But anyway, we're going to use the one that came with this soldering iron. I'm using this variable thermostat soldering iron. So we're going to pull this down, and then we're going to heat this up. Alright, so now I'm going to get a paper clip. Actually, I'll just get one of these resistors here. And push that out. Get it turned sideways. Alright, so now we can take this one. Remember, the words came this way. So we'll put that down in there. Hopefully. You just watched me poke those holes out, but I'm about half blind. So let me go over the magnifying glass so I can see where the holes are. Alright, so now I've got it slid in there, and we're just going to push that down till it's about, I don't know, about where it was. And then we're going to bend them over just enough to hold it back in place so that when you touch it, it don't fall back out. And then I'm using rosin core solder, lead free. Well, I don't think that solder is worth a crap. Let me get some real solder. We're going to use this stuff right here. This is what I'm used to. Silver bearing solder. I don't know what bearing means. So now we'll heat this up. Well, my soldering iron ain't working very good for some reason. I usually take a little bit of sandpaper and clean them off. Then you want to melt them to where they get a good melt. And we should have it. Alright, so now we've got that in. Now we can clip the backs off of it. And there we've got a new thermistor soldered in place. Alright, so now we shouldn't have that problem. So now we go ahead and put this back into the case. Alright, so now we've got it all back in. So now we had another problem. These fans in these things are notorious for going bad or getting real loud. So I didn't know how to measure for fans, so I ended up buying 2 sets of fans that I didn't need but one. But I thought these were 80mm fans, but as you can see, it is not. This one is a 16 volt. This one is a 24 volt. Now, I don't know if they put a 16 volt in here or not, but I don't have another 24 volt and a 60mm fan. I got a 12 volt, I got a 12 volt, and I got a 16 volt. The 16 volt will work until I get a new one. So that will get plugged in. And then we will attach it to the cover. So let me go get my screws and we'll be right back. Alright, so we've got our fan screws. That's just them big old fat ones. And we're going to mount this in here. Now this is just temporary, because I've got 60mm fans coming. But you can use a 16 volt. Yes, it will run a little faster, a little harder, But the way I use this, I turn it on and then I turn it right back off when I'm done moving my Z-axis. So now we can put this back together. Alright, so now we've got our spades and our wire. So now we need to strip these down. Alright, so then we got these three are negative, these three are positive, 24 volt. So we're going to be testing this one and this one. And you notice that jumper is on the ground from the line in and jumps over to this to give it its negative. So now, remember we got that 16 volt fan in there. It's probably going to be a little loud, but we're just testing it out right now. So let's plug it in and watch the sparks fly. Alright, we have power. It didn't pop. Hell, the fan sounds good. May not have to sound. So that's a 16 volt. I think they actually put 16 volt fans in these things, but we're going to go ahead and test it here and see what we got. So we're going to put that on DC, and we're going to touch our ground. I got fuzz all over it. And look at there, 24 volts. 24 volts. 24 volts. All the grounds work. Alright, we are back in business, guys. So we're done with it. I don't have to take it back apart now. So, because that fan's going to work. So, I went and ordered some 24 volt fans. Didn't realize a 16 would have worked, but that sounded really good. It wasn't loud, it wasn't over revving. Now, if you was to take this off and put one of these 12 volts on there, that thing would be screaming. Because you're about half the power more than you should have. So there's the power supply ready to go back on the mill. Now I'm going to do some modifications to this one. I'm going to actually put a on-off switch on this in line with the neutral or the power. I might use the line, but that's how you replace one of these busted thermistors in your Chinese power supply. Now the 12 volt one also has the same thing. So I don't know what made that blow up like that. I'm hoping there's no other components that's going bad that's causing that to be overloaded. I don't know. From what I understand, it's to keep voltage from going back into the line, into the wall. I'm not sure how it works. I just know that it works. And if you see one that's busted like that, just replace the damn thing and go on about your bad self. And it's even got a hole in the backside of it. That thing was really arcing. Because every time I turned my mill on, I kept hearing this pop sound. Sounded like a high voltage spark. And everybody knows what the high voltage pop sounds like. So now I've got 9 more fixes if I ever have another power supply go bad. So I don't know how I'm going to fix the 12 volt one, because I bought a 12 volt one for my parts washer for lights and to run the 12 volt pump, and it was only giving me 10 volts. So I don't know if I can fix that one. That's a little too deep for me. Replacing capacitors and, you know, parts that's obvious, that I can deal with. But when it comes down to testing all this stuff, I'm not very good at it. So, and I even went to school for it. Anyway, hope you guys got something out of this and learned something. Before I go, I want to show you the buck I got this year that my deer jerky came out of. Got my fishies there. There is my big buck. He's a kind of a funky looking buck, because you notice here on this, he's got 2 little tits on one instead of it growing right here where it should have. So this one is kind of bent back further. That's why there's a gap in between it right there. I don't know how he ever fought anything to get any poo-tang. But I mounted that. I just found some old fuzz and put it on there. 2023s when it was killed. So anyway, don't forget to like, share, comment, subscribe. You guys have a good one. Later.